Section 1.7 in Intermediate Algebra deals with the concept of scientific notation. This is a very short section that we'll cover quickly, but now that we have talked about exponents and their properties, we can use some of those properties to do calculations with numbers in this particular format. It turns out that if we're going to be dealing with very large numbers or very small numbers, our typical notation for numbers is not very kind to that situation. It's very tedious to keep track of numbers in the billions, trillions, quadrillions with many, many decimal places. And there are applications, particularly in life sciences or even chemistry, where you're dealing with very large numbers, like Avogadro's number when you're talking about the number of molecules in a mole of gas, 6.02 times 10 to the 23rd. It's not something you want to write out by hand in full form, but scientific notation allows us to summarize large numbers into fairly shorthand notation, and that's what we're going to deal with in this section. The lecture outline for section 1.7 covers the following essential concepts. We will learn how to convert from scientific to decimal notation. We will learn how to convert back from decimal notation into scientific notation. We will also learn how to perform computations with numbers that are in scientific notation and use scientific notation to help us solve some specific problems. Let's begin by writing out a definition for scientific notation. We say that a number is written in scientific notation when it is expressed in the form a times 10 to the nth power. That's not x, that's actually a times symbol. I'll use the old school way of writing times for now, where the absolute value of a is greater than or equal to 1 but less than 10. Okay, so it's something between 1.0 and 10. And the n is some integer, could be positive or negative. So for example, the number 2.037 times 10 to the negative 6th. That is an example of a number in scientific notation. Notice the number times the 10 to a power is somewhere between 1 and 10. And the integer up here is a negative number. We could also have something like negative 1.291 times 10 to the positive 8. That's another example of a number in scientific notation. Now, what does that notation actually mean? Well, to understand it, we need to be able to convert from scientific notation, this form, into decimal notation. And here's how you do it. If the n, the exponent, is positive, you move the decimal on the a to the right. Positive is right. That many places, and fill with zeros. Fill the empty places with zeros. If n happens to be negative, then you move the decimal to the left and also fill in with that many zeros. Okay? So for example, negative 2.6 times 10 to the 9th is the same thing as the following number. I'll leave 2.6, I'll write it just as it is, and I'm going to take the decimal place and I'm going to move it to the right 9 places. And I'm moving it to the right because 9 is positive. So I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9. Fill the empty places with zeros, and that's your number. So this number is actually 260000000, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. So putting the commas in, we recognize that as 2,600,000,000. Right, now if you're doing a calculation with this number, it is actually much more efficient to write negative 2.6 times 10 to the 9th than it is to write it out in this full form. Okay, what about 3.017 times 10 to the minus 6? Well, we take 3.017. Now I'm going to move the decimal place to the right. No, to the left 6 places. So 1, 2, 3, 4, 5, 6. And fill in with zeros. Notice how a negative exponent means you're a very small number, close to 0, right? 0.000003017. is this number in decimal form. Of course, if we can convert from scientific to decimal notation, we should be able to go back the other way. So if I have a large number or a very small, tiny number close to 0, I should be able to write it in scientific notation. In fact, I can do it with any number, whether it's large, small, or even medium to normal number, right? If you want to write the number in a times b to the n, first thing you do is you determine a. You move the decimal point in the given number to obtain a number whose absolute value is between 1 and 10. You move the decimal place just to the right of the first non-zero number as you go from left to right. Okay, it's just to the right of the first non-zero number from left to right. Then you determine n. The absolute value of n is the places the decimal point has moved, and if it was moved to the left, right? Well, let's say it this way: if it's moved to the left, so if I had to move the number to the left to get to where it is, like from here, if I had to move it back to here, that means it's positive. And if you have to move the number to the right, it's negative. Now, just so that you don't have to keep track of right and left here and right and left here as being opposites of each other, here's what I would remember. If it's a large number, bigger than 1, then it's positive. If it's very small or tiny, it's negative exponents. Okay, let's do a couple of examples. 5,210,000,000. The decimal place is understood to be here. I'm going to move it to right here. So how many places do I have to move it? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I have 5.21, and I moved it to the left 9 places. The original number was very large, so I know it's going to be a positive exponent, so times 10 to the 9th. Okay, now I'm going to move this decimal place right to the right of the first non-zero digit. Okay, so I have negative 6.893 times 10 to some power. How many places did I move it? 1, 2, 3, 4, 5, 6, 7, 8, and the original number was tiny, so it's to the negative power. There is that number in scientific notation. Now, your calculators will have a button on them for scientific notation. Sometimes you see this on the screen. You may or may not have recognized this. Whenever you see the little EE, or sometimes there are little subscripts on your calculator screen, that means scientific notation. The number that follows the EE is the exponent of the 10. Now, if you're going to do computation with scientific notations, all I encourage you to do is use your calculator, although you can do this by hand. I'll show you how to do this by hand, but you're just as well off using your calculator. Let me show you. This example right here, if I were to enter that in my calculator, what I would type in is 6.1. I'd hit that E button and then type a 5, and then times 4. I hit the E button. I'd hit negative, actually what I'd hit is 9, and then I'd hit my plus or minus key to change the sign. Okay, and then I'd hit equals, and that would give me an answer in my calculator, which is just as good for me as anything. Now, the other thing that you could do is if you wanted to do this by hand, you could use our rules for exponents from the last section. What you can do is multiply the 4 times the 6.1, giving yourself 24.4, and then you could multiply the 10 to the 5th times 10 to the 9th, negative 9th. Right? You add those exponents together to get negative 4. Now, technically, this isn't scientific notation because this number isn't between 1 and 10, but I can move this one place to the left, okay, which means I am moving it left, so I'm moving it one more place, means a positive 1. I ended up with 2.44 times 10 to the minus 3rd. Okay, if there's any confusion, convert it all the way back to a decimal, which would be moving it 4 places. You get 0.00244, and then convert it back into scientific notation. Clearly, it's 2.44 times 10 to the minus 3, but that's one way to do that by hand. I recommend the calculator, and I have no problem with you making use of the calculator in this case. Division would work the same way. Again, I could do this in my calculator, or I can do this by hand. Doing 1.8 divided by 3 is 0.6. Okay, and then if I'm going to divide 10 to the fourth minus 10 to the second is going to be 4 minus a minus 2, or 0.6 times 10 to the 4 plus 2, right? Minus a minus 2 is plus, so 10 to the 6th. But this is also not between 1 and 10, so I have to move the decimal place to the right 1, which means subtract 1. I end up with 6 times 10 to the 5th is my final answer. Other places where you might need to use scientific notation would be in word problems, so let's just take a quick little application here. In 2001, the U.S. government collected 2.13 times 10 to the 12th dollars in taxes. That's actually $2.13 trillion if you were to write that out. At the time, U.S. population was approximately 286 million. Find the per capita tax. That means tax per person, rounded to the nearest dollar in 2001. So we would take 2.13 times 10 to the 12th. That's dollars. Okay, that's the taxes, divided by the number of people, 2.86 million. Sorry, 286 million, or 2.86 times 10 to the 8th. Okay, so I'll divide that. In fact, I'm going to pull out my calculator and do that right here by hand. So I take 2.13 EE12 divided by 2.86 EE8, which gives me, and it go ahead and puts the number in traditional notation, 7,447.55. The reason I go that far is because this is a dollar amount, dollar per capita. Okay, that's the average tax per person in 2001. Okay, scientific notation is relatively easy concept, so you shouldn't have much trouble with this. If you have any questions, feel free to email your instructor. But that's the end of section 1.7 and the end of chapter 1.